Okay, let's talk about our first new thing for the new unit. So if I've got your basic coordinate plane and I say, given a point that is at the end point of the terminal side, so that's the end point of the terminal side of the angle. And it said, I want you to find all the trig ratios for that point. So you'd say, oh, that's easy enough. I can just go over here and say, okay, so if that's 0.3, 4 right there, you're thinking, well, what the heck? How am I supposed to figure out all this stuff? Well, remember our angles are always the central angle right there. So then you'd say, oh yeah, well, this is 3, that's my x, that's 4, that's my y. Then, oh, I can use Pythagorean theorem to find that missing side. And I know I made this one work out nice and neat just for this example. Then you can go, oh, so I can fill out the rest of this real easy. So the sine would thus be 4/5. So the sine is 4/5. The cosine is 3/5. Adjacent over hypotenuse. Tangent, opposite over adjacent. Then flip these guys over. And I know I made this easy just for the example. So if you had to, you could flip all these things. Okay. So first quadrant. There you go, right there. You just drew the triangle and it all fit together nice and neat. Everybody says, oh, that's no big deal. I can do that. That's easy. Okay. So let's make it a little weirder. What if our point was -3, 4? So you'd say that's still no big deal because I just go to here because now I'm in the second quadrant. So that would be -3, 4. Do the Pythagorean theorem. That turns out to be 5 again because we squared the negative and it became positive. Now, then the question is, what's our angle? Because on one hand, you'd say, well, my actual angle would be this guy right here. That'd be the positive angle. But what we're going to do is we're going to think about this guy, which is the reference angle. We're going to think about this guy, which is the reference angle. That's going to end up being the angle we're going to take the trig functions of. We're actually going to look at this guy here. We're going to look at that guy there and say, that's the one we're going to take our trig functions of. It's the reference angle because that's where we can make a nice right triangle. So maybe I should call it R. I don't know. Anyway, whatever the case. From here, you just say, oh, that's still easy because sine is opposite over hypotenuse. Cosine is, wait a second, I got a negative. Well, that's okay because it's still adjacent over hypotenuse. Tangent, -4/3. Then once again, you flip all these. And like I've said, I made this example kind of easy. Okay, so wait a second. In the second quadrant, x is negative, and that made cosine, tan, secant, cotan all negative. Sine and cosecant are positive. I wonder if we're going to develop a pattern based on that. I wonder, is there going to be a pattern that's going to come out of that? What if we did the same thing for -3, -4? So -3, -4, now we're out here. -3, -4. -3, -4. I do the Pythagorean theorem, square the negative. The hypotenuse turns out to be positive. What's going to happen is whenever we're doing these problems, the hypotenuse is always going to be positive. So, oh, we do the same thing again. This is easy. We'd say sine. See, here's our angle again. We're going to look to the reference angle, the angle right there at the center. Here's our angle again. Oh, opposite over hypotenuse. So, but now it's negative. Uh-oh, now the cosine adjacent over hypotenuse. Now, wait, that's negative. The tangent would be -4 over -3. Negative over negative. Oh, so that becomes positive. Then just flip all these guys over. And so hold on. In the third quadrant, where we were negative, everybody's negative except tan and cotan. Everybody's negative except tan and cotan. I wonder, is there going to be a pattern that's going to emerge out of this that I'm going to blab about a whole lot? So let me see. In the fourth quadrant, if I do the same thing for the fourth quadrant. So let me see. We'd have +3. Uh-oh, now it's at -4 is the y. Hypotenuse still turns out to be +5. The hypotenuse is always going to be positive when we do this. So now the sine is still opposite over hypotenuse. Cosine is still adjacent over hypotenuse. Tangent, opposite over adjacent. Now flip all these guys over. And interesting. Now this time, cosine and secant are positive. Everyone else is negative. So what this amounts to is a bunch of things. A bunch of things we're going to get to. But what this amounts to is in the first quadrant, everybody was positive. Second quadrant, sine and its reciprocal were positive. Everyone else is negative. Third quadrant, tan and its reciprocal positive. Everyone else is negative. Fourth quadrant, cosine and its reciprocal positive. Everyone else is negative. So here's what happens first. First thing, I strongly encourage you to just memorize. Strongly encourage you to just memorize this. First quadrant, all 6 are positive. All 6 are positive. Second quadrant, sine and its reciprocal are positive. Everyone else is negative. Third quadrant, tan and its reciprocal are positive. Everyone else is negative. Fourth quadrant, cosine and its reciprocal are positive. Everyone else is negative. So this is one of those patterns I keep talking about. Memorize patterns, 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 patterns. Memorize patterns. We're going to say this all year long. This is the mnemonic we use. All seniors take calculus. All seniors take calculus. All seniors take calculus. First quadrant, all 6 are positive. Second quadrant, sine and its reciprocal are positive. Everyone else negative. Third quadrant, tan and its reciprocal positive. Everyone else negative. Fourth quadrant, cosine and its reciprocal positive. Everyone else is negative. And you can see that based on the values we came up with right here. Okay. And just for the record, check out what would happen here. See how when we did this, we had, if we were on a circle, we're making an angle on a circle. Pretend this is a perfect drawing like all my drawings. We're making an angle on a circle, making that right triangle right there. Making that right triangle right there. So this guy was X, this guy was Y. This now is the radius of the circle. That's the radius of the circle because we're making our angle based on a circle, which means when I start thinking about my trig ratios, now sine, instead of being opposite over hypotenuse, I can say, well, sine is now the y value over the radius. Cosine is now the x value over the radius. Tangent would be y over x. Flip all these guys. Now, then, just to be a nerd about this, we're going to get to it in a minute. When we're on the unit circle, remember how we standardized the unit circle? Unit circle, the radius is always. So on the unit circle, what was the radius always? Okay, 1. Somebody says 1. On the unit circle, the radius is always 1. So if I'm strictly on the unit circle, then sine, if r is 1 on the unit circle, then strictly on the unit circle, sine just becomes the y value of our end point. Cosine becomes the x value. of the endpoint. Tangent is still y over x. Cosecant would be therefore 1 over y, 1 over x, x over y. So when we're on the unit circle, since r is standardized to be 1, we strictly have these values here. All right, so we're going to have to practice this a little bit and get to some other possibilities here.